everyone, how are you today? I hope you're always good. Are you ready to learn? Okay, before we go to the topic, let me introduce myself. My name is Alfiah Fitriati. My student ID is 430141708. I am for 17th class chemistry education. The purpose of this library is expected that you can understand, observe, and analyze the experimental result of the qualitative measure in electronic and non-electronic solution correctly after we following this learning. Please take your attention in this slide and I will explain it.
Which of you have eaten es dundung or es puter? Anyone know how to make it? Yeah, it was made without using refrigerator, through adding ice, of course, and salt as a cooling system. But what salt? And have you ever seen salt used to melt snow on the road? Again using salt. And the last, which of you use Presto pen? What is different from ordinary pen? Okay, we will know the answer after studying this material. Colligative property is a property that is dependent on the number of solid particles dissolved. It is an intrinsic property. It doesn't depend on the identity of the solid. It's simple depends on the quantity of solid that dissolved. There are any four colligative properties that you are need to be familiar. The first one is called boiling point elevation. The second is freezing point depression. The third is vapor pressure lowering. And the last, osmotic pressure. Boiling point elevation. Keyword elevation. Whenever you add salt to the water, the boiling point goes up. The boiling point of the pure water is like 100 degrees Celsius. However, when you add salt to it, it increases like maybe 102, depending how much salt you add. But the boiling point goes up. The more salt you add, the higher the boiling point is going to continue to increase. So that's why it's called boiling point elevation. Now you might be wondering, okay, how does salt doesn't impact the boiling point of the water or of the solution goes up? So let's use sodium chloride as an example. So in the sodium chloride, we have sodium ion and chloride ion. The presence of this solid particle it makes the water molecule more difficult to escape into the gas phase. They need more energy, and so you have to add more heat to get water to escape from the gas phase. The boiling point gets up. The temperature that's required to boil water increases. So the presence of the solid particle shortly blocks the water molecule from entering the gas phase, so it makes it harder, and that's why boiling point increase, because you need more energy to basically the water leaves need more energy to escape to the gas phase. Then how to the equation for boiling point elevation look like this. Its delta T is equal to Kb times m times I. The Kb is the boiling point elevation constant, and in the case of water is about 0.51. Since as you guess, it is molarity, and I is the Van-Hoff factor. Delta T is the temperature difference between the solution and the temperature of the pure solvent, in this case pure water. Now, molarity is defined as the moles of solute defined buying the kilogram of solvent. So that's how you find molar is. Now the next thing we need to talk about it is the find half factor and how to calculate. For a non-electrolyte like glucose, this is sugar, this doesn't dissociate into ions. So for an electrolyte, the find half factor is 1. For electrolyte like sodium chloride, this complete ionized into the ions. So because you have the sodium ions and chloride ions. So because there is 2 ions for formula unit, the factor find half is 2. And now what about like magnesium chloride? Magnesium contains 1 ion and we have 2 chloride ions, so there's a total is 3 ions. So the find half factor is 3. In the case of aluminum chloride, aluminum has a 3 charge and it's paired up with 3 chloride ion. So there are 4 ions for performance unit. So the find half factor is 4. And finally, what about let's say aluminum sulfate? How many ions in this particular compound? So we can see that there are 2 aluminum ions, 3 sulfate ions. So therefore the volatile factor is 5 because there are 5 ions per performance unit. So the more ion unit have, the greater the boiling point of the solution will be. Now the next step of quantitative property that you need to know is freezing point depression. So if you think of the word depression, that means it's like down. Freezing point depression is tell you that the freezing point of the solution decreases whenever you add salt to it. If you think of in winter time, salt is usually added to ice water. What happened?
Salt helps melt the ice and thus clear the roads. What? But how, dude? The freezing or melting point of water is about 0 degrees Celsius or 32 degrees Fahrenheit. When temperature drops below the melting point, the water molecules bond together to form solid ice. However, when temperature rises above the melting point, the bonds break and the ice melts, forming liquid water. Now, when we add salt or sodium chloride to ice, it lowers the melting point, causing solid ice to melt and form liquid even at temperatures below 0 degrees Celsius. Then, the salt dissociates into liquid water, forming sodium and chloride ions. These ions make it harder for liquid water molecules to again bond together and form ice. Hence, the melting ice does not refreeze and thus helps clear the roads.
And so that's why ice is added to. I mean that's why ice is added to ice during the winter, so it's hard as the freeze the roads don't get icy and you can drive on them without sliding and good accident. Then the equation for the freezing point depression is delta T is equal to negative Kf times N times A, where Kf is freeze point depression constant, M is molarity, and A is find half factor. Delta T is the temperature of solvents means temperature of solutions. M is small solids. Now the purpose of negative sign is to show you that the freezing point will decrease. So if you have a pure water solution, it's going to freeze at 0 degrees Celsius. But if you have, let's say, a salt water solution, the freezing point might be snake like this. It could be like negative 8 degrees Celsius. So you can see the freezing point of solution is lower than that of the pure solvent. Now the next qualitative property is vapor pressure lowering. If vapor pressure and boiling point are inversely related, whenever the boiling point of a solution gets up, the vapor pressure gets down. So when you add salt to the water, because the hard form water molecule to escape the vapor of the gas phase, the vapor of the solution is always less than pure solvent. Molecule of solution make the water molecule harder to escape the vapor of the gas phase. Now, how to calculate vapor pressure lowering? If you want to calculate the vapor pressure of the solution, it equal to the mole fraction of the solvent times the vapor pressure of the pure solvent. And so that's how you can find it. Now, in order to find a mole fraction of solvent, let's use the mole fraction of water. You need to get the mole of water and divide it by the total moles, that the moles of water, and the moles of water solid particle. And now the something need to be aware of this equation. Let's say if near 1 mole of glucose, so the mole of solid particle will be 1. However, glucose is non-electrolyte, and the whole factor to 1. But let's say if you have sodium chloride, if you 1 mole sodium chloride, keep in mind and find how factor is 2. So when you are calculating the mole fraction of water, you need to incorporate it to somehow. So the mole of solid particle is not 1 mole of natrium chloride. In fact, it's 2 mole of ions. So if you have 1 mole of natrium chloride, what you need to prove here is not 1, but it is 2. Natrium chloride is an electrolyte. If you are dealing with solid particles that are electrolyte that can ionize in water, so make sure you are aware of the fact of that's going to help you to get the right answer. And the last qualitative property is osmotic pressure. Watch this video.
Special case of diffusion that involves the movement of water molecules across a membrane is called osmosis. If a molecule such as urea is added to one side of a membrane, it will not be able to diffuse across the membrane because it is both large and polar. Because of its polar nature, it will interact with other polar molecules such as the water. This interaction reduces the number of free water molecules on the right-hand side. With fewer free water molecules on the right-hand side, there is now a net movement of water molecules down their concentration gradient to the side with the urea molecules. Because more water molecules are moving into this area than are leaving, the water level on the right side will rise. If the osmotic concentrations of two solutions are equal, the solutions are isotonic. However, when the solutions have unequal osmotic concentrations, the solution with the higher concentration of solutes is hypertonic, and the solution with the lower concentration of solutes is hypotonic.
And now, how to calculate the osmotic pressure? is P equal to mRT times I. M is the molarity. It's equal to the moles of the solid particle divided by the liter of solution. R is the gas constanta. It's 0.082. And T is the temperature, but in Kelvin. And keep in mind, the Kelvin temperature is the Celsius temperature plus 273. And I is the Van Hoff factor. Okay, pay attention to the unit of the P into liters times atom per mole times Kelvin. So if you put the units all together, let me rewrite the equation first. So molarity, we said it's mole per liter, R has unit liter, times atm per mole times Kelvin. And the temperature is in Kelvin, and the Van Hoff factor is useless. So as you can see, the unit Kelvin cancel, the mole cancel, and finally the liter cancel, which means that the osmotic pressure is in atm.
Thank you for your attention. I hope what we learned today can be useful for